Hi there. I'm Harmanpreet. I work at Diligent, basically Galvanize, which is brand of Diligent. I work as a software engineer in test, has been here for last 3.5 years. And in terms of experience with AWS and serverless, like our team transitioned from our desktop-based application development to a serverless application. So like this is also like new to us, but like I have been working with almost one or less than 1.5 years. And we picked up some of these things on the way that I will be sharing today with you guys, and hope we all learn from there and take it to next level. Few coaches, I have placed asking question placeholders in my presentation. So if you have any, please feel free to drop in the chat as well. I have a challenge for you guys. So this is the challenge. While my presentation, I'm going to bore you. I'm going to bore you to hell. So the idea is you guys need to stay active. And if you feel bored, or if you see I'm being bored, you have to keep me on my toes as well. All right, so we all agree what are the expectations from my side, and hopefully I reach your expectations as well. All right, let's get started. So today I'm going to share a story from a guy named Drew, who is founder of a startup, and now he wants to build a web application. And for that, he hired 3 members. First one is Dr. Nefario. He is the R&D director, and Kevin and Dave, who are basically employees in the R&D. So now we will look into the story, and we will develop step by step. Okay. So first of all, Dr. Nefario and Drew are going to have a kickoff meeting. So they will start deciding on the key goals and the expectation on the test setup side. They want to build a serverless application. Serverless architecture is a way to build and run application and services without having to manage infrastructure. So it is like pretty fast and easy to build the serverless application for them. So they want to build this. And they also want to have a solution, basically a serverless observability solution. Then they are saying that they will provide 99.99% of SLA to their customers. So that's a pretty huge expectation and trust with their customers. So the idea is they want to test the up and running their application at high frequency. Since there is high frequency testing involved, obviously there will be a cost to that. So the idea is to keep that cost, that test setup cost, as low as possible. Then again, for high frequency, if you're let's say running every minute, the idea is that test setup should be really fast, and it should basically load up really, really fast so that they don't waste time just on the loading part. They should basically run the test as much time they want to spend there. And last, they want to write less code. Basically, for same amount of code, they want to get more benefits. So now, R&D director, our Dr. Nefario, is going to have introduction with their team and set up the agenda. So first thing, Dr. Nefario is going to share with his team, like what kind of testing mindset should they have, the entrepreneurial mindset. Then he will basically, so there are no questions, so he will also share like, what does it mean to test a standard service versus our serverless service? Then what are the ultimate solutions that they can use? And then the test programming for their work division. Let's see. Then the second part of this agenda is system level test layer, where Kevin, one of the employees, is going to introduce us with AWS Synthetic Canary. What are the runtime libraries available for us? Then security consideration and cost analysis for the solution. Then Dave, another employee, who is going to work on the service level test layer, and he's going to introduce us with the LambCI Lambda. And then there will be a conclusion. Before I get started further, I want to share some terminologies that we will be using throughout the presentation. First one is AWS CloudWatch Synthetics. So it's an AWS service which supports monitoring REST APIs, URLs, and web content. Then the second one is AWS Synthetic Canary. Now, this is the script that monitor our application endpoint and API. System level test layer, I just used this in last slide as well. So this is the level or layer where our tests run against real application. Then we have service level test layer. Here, we are going to run tests against one or more service of that application, but kind of at local level. All right. Are we excited to get started? hopefully, let's get started. Okay, how many % does it take to test a product? Usually, I would say SCT or a QA myself, or maybe I will shy away and say it's a team responsibility. Quality is not single person, it's the product, and that product is built by a whole team. So that whole team is responsible for that product's quality, right? For testing of it. But we still have customers who report production bugs. So it takes the actual customer to verify everything for our side. Now, let's jump into that testing mindset that Dr. Nafario mentioned earlier, the entrepreneurial testing mindset. So what are the factors that should be considered? The cost of setup, development, deployment, the time spent on it, it should be as minimal as possible. Let's consider these on the testing side as well. Then the continuous delivery. You have to build your product, you have to send it to production, and you might want to have high frequency. The idea is maybe a number of times a day. Then there should be a feedback loop, right? So once you have released your product, we want to verify that product is successfully released, or we have to make a rollback decision. So there should be such structure set up to make that decision. And the last one being agile. Is it possible to say that after I release this particular product, it will be 100% bug-free? No, I don't think so. And it might be impossible for most of us. Maybe we have a superhero there, can do that. So the idea is to mitigate those risks and then resolve them, but before our customer found us. So our solution will be focused on these factors somewhere or other way around the corners. All right, we are talking a lot about the serverless, right? As this is that the startup is going to build a serverless application, why do I have to use serverless observability? Like, what's the difference there for standard service, testing a standard service or testing a serverless service? For this particular example, I'm taking a high level, like for standard service, let's say EC2 instance. Then on the serverless side, let's say Lambda. So you want to test in your own environment. You might want to launch your own application environment, or you might want to run against actual environment. So what are the different parts of this, right? So on the standard service side, is either you need to boot that up, or it should be always running. But in the serverless, and on the serverless side, like it's event-driven. I just invoke it, boom, my test run. So let's say if my tests are running maybe every 1 minute or every 5 minutes, every hour, or on certain interval, there's some idle time. So either on the standard side, I have to boot up my service every time, or basically I just keep it running. And then like there will be idle time involved, which will basically cost us. On the serverless side, we just pay for usage. We don't need to pay for the idle time. On the standard side, we have to test for scalability. On the serverless side, it is auto-managed by AWS. So basically, I don't need to even test that part. I trust my provider. Again, on the standard side, the applications are stateful resources. There might be a single large application with database and everything on a single EC2 instance running on containers or something. But on the serverless side, these are stateless resources. The service might be divided into individual resources, as on multiple Lambdas. One Lambda just do one job at a time. So I can basically test into those service resources into individuals. So it's pretty easy and faster. Okay. So far, like we have two major factors at high level to think about. First is the entrepreneurial testing mindset, and second one is the serverless observability. So from the testing side, if we combine those two, what are the solutions we have? What are the ultimate solutions that I can implement and use them to test my product and be efficient in my work? All right, here is Kevin on the cloud side. He says, we have AWS CloudWatch Synthetic Canary. Use it, and we will see soon that how it is really beneficial to use this and what are the different parts that are really convenient for us. And on the local side, Dave says it's LambCI Lambda. Oh, we will look in depth into those. Now we know what we're going to do, but we need to divide our work into certain parts, which logically makes sense. Now let's look into the test parameter layer. You might already know about this test parameter, right? So for an application, from testing side, we can divide whole project testing into different layers: unit level, component level, service level, then service integration and system level. But at the purple marker, so everything below, which is service integration, we can test them locally and save some cost. And above it, we have system level. So the tests are running against actual application. And there we can use AWS CloudWatch synthetic canaries. And for local, we can use LambCI Lambda. Nice. All right, this was the part. Our first chapter is over with the introduction. Now we are moving into the second chapter where Kevin is going to work on the actual system to test us. And the idea here is that he will basically introduce us to AWS synthetic canaries. Then what happened under the hood? What are the runtime libraries for us to work with? What are the security considerations that we should know about? And the cost analysis for using this service. Okay, the first one is system level test layer. First question as a curious SET or employee came to mind is, okay, man, why do I even need to run my test system layer? What's the benefit? I can just run them locally, as you mentioned earlier, right? No, the idea is to check the availability of your application. Web application is always there. So we want to verify that. And also we want to capture any problem before our client does. So that's why we are going to use or run our test at system level test layer. Okay, now you remember that AWS CloudWatch synthetic canary? Yeah, let's look what it is and what are the benefits. Why do I use it? So it can help us monitor REST APIs, application URLs. We can verify availability of endpoint, which I just mentioned. We can verify latency of endpoints. Or let's say if you're loading a web page, we can verify different latency for UI assets on that web page. We can verify if there are errors, 404, 500s, or any other errors. If there are any broken or dead links, we can also verify complex user flows using this synthetic canary. Then, what are the other benefits? Let's say we can check for unauthorized changes. If there's any phishing attack, any code injection, or cross-site scripting. All right, that's too much talk, right? Now I might be winning because I'm boring you guys. So I also want you to win. So you should be active now. So now the idea is we are going to create and configure synthetic canary. I have a pre-recorded video that I will be playing. The sound is a bit lower, so please turn up your volume and we can get started with the configuring and creating the synthetic canary. Can you hear the voice?
As there is no volume. Yeah.
All right, just give me a sec. Let me share again with the volume. Can you see my presentation again?
Yes.
Right. So the volume is really low. Please turn it up. Let's look into how we can create canaries. To create canary, we need to write some piece of code. And the first option we can use is a blueprint. So AWS Synthetics provide us with 6 templates, 6 different blueprints that we can use to write our canaries. Another way is to write your own script using inline editor, or we can just import our code from S3 bucket. If we choose the first option of using a blueprint, there are 6 ways of doing this. The first one is using a heartbeat monitoring. So in this one, we just provide the endpoint or application URLs. Each URL will be loaded and there will be a screenshot taken for that. And there will be logs for each step, and there will be HTTP archive files for all of them. Then comes the API canary. So this API canary is used to monitor our API HTTP steps. And this one, we just verify the read and write functionalities of APIs. It supports API gateway as well. So we can connect with API gateway from same account or cross account. Then comes the broken link checker. This is pretty interesting one. So we just provide an initial entry link, a website maybe, and then we need to just provide how many links we want to check. So this crawler will go over web page, get all the links, and then try to ping all of them one by one and verify that all the links are working fine. So it checks if there is any page that we are not able to load, any 404s, invalid hosts, bad URL, any dead links, if the server is respondent, or let's say if there are any other links that are being timed out constantly. Then comes the AWS recorder. This is also an interesting one because in this one, we can use a Chrome extension to record our workflow, and then we can just have that workflow copy pasted as a script here, and then we are good to proceed further. The fifth one is the GUI workflow builder. In GUI workflow builder, we provide different actions to verify on the web page that we have loaded. So like we can provide the clicks, we can verify text, we can verify certain selector is there, we can verify certain input is there, we can type our input, we can click and navigate to different pages. So this is like a actual user workflow, actual user actions being taking place. Then comes the visual monitoring. In visual monitoring, it's almost same as other visual ones, but this has some extra features. So it load a page and capture the screenshot. And then the first run is considered as a baseline, and the other consequent runs are. Sorry, I just hear some noise. Are compared with the baseline. So once you have screenshot, you compare if there are any changes using the visual variants. Also, you can decide which part of page you want to compare and which part of page you want to leave out of the comparison. So once you have selected the option that you want to use, then you just need to provide the name and the, let's say, the entry or endpoint URL that you want to monitor. You can choose the runtime. Then you can see the script is auto-generated. It will be basically edited based on our choices. We can provide the environment variables that we want to use. Then we can set the schedule. So then we can set the frequency to every minute, or let's say every n minutes, or let's say every day at this time. Also, we can choose cron job. So we can just provide a cron expression, and it will just trigger based on that. Or we can just decide to run only once. In additional configuration, we can set the timeout. If we don't set this value, the timeout will be based on what we have in our schedule. So we can choose data retention time for our failure and success data. We can also provide a custom value based on our choice. Then we can choose where we want to store our data. This could be an existing S3 bucket, or we can create a new one from console. In additional configuration, we can choose how we want to encrypt our data. Then, like, we can decide if we want to use any existing IAM role or create a new one, the alarms that we want to create, if we want to connect this Canary to a VPC or run it under a VPC, then the tags, if you want to add any, then the tracing. So these extra traces are pretty useful when we have to debug. So click it and then create a Canary. All right. So in this one, like we saw the blueprints, as well as you can mix and match when you write your own script. Okay. So let's go to the next part. All right. Great. We saw how do we create a Canary from basically scratch. So now let's see what are the output of that Canary. What are the results that we get from that synthetic Canary? Like that's our goal, right? That's what we want to get from the synthetic Canary. All right. Let's go into another video, but this time this audio should be fine. So let's go, and then we will address some of the questions if we have. Let's check what information we gain using AWS synthetic canaries. For this demo purpose, I'm using this dashboard, which basically runs a canary script that make an API call to example.com. So let's go through this dashboard with different parts of dashboard one by one. So first of all, I see the information regarding the timeline when my canary ran and what was the result. So this blue dot basically means they all pass. And if there was a red dot, that basically means a failure. And then we see the % of that success or failure rate. Further, as I mentioned, we just have one API call in this one to verify example.com. And now I can see the information for that API step. So for my step, I have basically disabled request headers, response headers, allowed request body here. So in this one, I can see all the other information is empty, or basically it says not enabled, and the one that I'm expecting, so basically that information is present here, which is empty again. So another part is the HTTP request. So during each step execution, there might be multiple HTTP requests being made. So let's say when I load a website, there will be requests to CSS files or other responses. So those are also captured, all the API calls, which we will see in the next example. In this one, we just have one call, example.com, and then the information regarding that. Further, for each call, each step, like we can see the status, the description for passing, or if they were failure, then we can see the error here, and then the duration. And this duration is divided into further network steps, so I can see where the whole time is being spent. We have traces. These traces are pretty useful when we have to check like where we spend the whole time or where the bottleneck is. So in this case, I can select any of my trace here, and then I can verify the information, what kind of calls were made and where the time was spent. So let's say in this particular Canary script execution, I can see the time it took to execute and then like time it took to upload all the artifacts to S3. So let's say if there were any further calls to communicating with SNS or communicating with the KMS or getting some information from other resources, they will be also captured here. Then comes the monitoring. So in monitoring, we can see all the metrics being captured for my Canary runs. So what's the average duration of execution, any Canary failure counts, Canary request 400 counts, Canary request 500 counts, success percentage, duration. Like again, this is the summary, and then we can have more details underneath. In the configuration, we have information regarding the runtime environment. So in this case, it's Node.js Puppeteer, then the Canary script that we use to run this particular test, and then the information regarding Lambda handler, the then Canary schedule or data retention. Let's look into another example. In this example, I have intentionally failed my test, and this example will show you like what kind of those failures are, because I'm loading a website and then I'm doing screenshot-based comparison. So if you check, like I select the latest failure stage, and I can see there were two steps being executed. One is loading www.wegalvanize.com, which basically failed, and I can see the description that it failed due to variation of the screenshot comparison, and the difference is more than 46%. And the second one is www.diligent.com, and this passed and everything is fine here. So let's look into this screenshot comparison, why they are saying it is failing or passing. So in this one, I can see the highlighted area, which is the yellow part, and I can see that these do not match, and then they basically failed because the variance is more than the accepted rate. Further, if you notice on the right side, I can see that there is content difference, but this is not being considered as part of variation, because when you create Canary, you can basically mark which parts of that screenshot or which part of your website you want to compare or which part you don't want to. So I have specifically mentioned don't compare my headers or this reason, just compare what's on the right side. So I can say there is variance of 46%, and then this yellow color highlights what those areas are. So in second step, as you can see, this step passed and there is a visual variance of approximately 6%. But I have defined that underneath, if this value is underneath, let's say within 10%, then my step should fine. So this is marked as pass step. Okay. Now, another thing that is pretty interesting is look into the HTTP archive reports. So as I mentioned earlier as well, once we load a website, there might be underneath a bunch of API calls being made. So all those calls are captured here. So let's say I was loading wegalvanize.com at a particular API address, then all the CSS font sizes, everything is being captured here. So basically I can look into any of these and verify where the time is being spent to debug this further. Also, as in first example, we disabled all the response headers, request headers, but in this case, we have enabled them. So I'm able to see all the information here, which also include the request header, the response header, and the other information as well. Now let's look into the metrics. In this case, I can see metrics regarding the failure as well as the passing. So if you check Canary step execution, I was doing 2 steps. So the green one which passed, which is the diligent.com, and the second one is the orange one which failed, which is the wegalvanized.com. So I have information regarding both of them. And this information for each step is shown in all the metrics. All right, let's check what information we gain using AWS synthetic canaries. Sorry, for this, let me stop this. So how are we doing so far? Am I winning the challenge or you guys are winning the challenge? Do we have any questions in the house?
May I ask one question? So it seems that Canary, we can use the servers. I mean, we can test any servers hosted or other than AWS.
Yes.
But is there any like no limitations? Like some features can be only used on the servers hosted on AWS, or basically we can use anything.
Okay, I will try to answer your question, and I do have something in the end to complement this question as well. So the first part is, let's say with this, basically we need a endpoint. So it could be any endpoint, a public or private, until the time you can ping it, you can make a call to it, you can test it. You can load any public website that you want to. But another part is in terms of, let's say, AWS services itself. You can, with the API Canary, we can call our API gateway, but we cannot call other services within the AWS. So that's kind of limitation, but like it also serves the main purpose for which I'm considering, which is the system now.
I see. Got it. Thank you.
Okay. If no more question, we can move to the next part, and then I will continue with the challenge. So keep me on my toes, okay? All right, let's move to the next slide, which is, okay, we created our canaries. We saw the results, but we don't know what happened there, how it got implemented, what AWS did underneath, right? So basically, the synthetic canary created a canary Lambda function for us, and that Lambda function contained our canary script and the Lambda layers bundled as dependencies, which we need to run our script. And this Canary Lambda supports Node.js and Python for Node.js. They have Puppeteer as web framework. For Python, they have Selenium as web framework. And they run against a headless Chrome web browser. So this is what's happening underneath. So now, like mostly we were saying that there's so much automation, but what if you need to write your own? Like what are the different functions? So here I'm going to show a few of the functions which are pretty important or critical ones if you write your own script, the Canary script. So let's say if you want to load a website, the UI-based testing, then you have to write a UI test, UI step. So they don't call it test, they call it step. So you have to write a UI step. Same for API, you have to write API step. Then for compliance and security perspective, I added this one as well to sanitize log reports and a bit more. So let's look into this first one to execute a UI step. So this is a simple function. The first parameter is step name, which is basically the name of that step. You can provide any string here. Then the function to execute. Thing to notice here is this: we actually don't make a call directly inside the execute step function. We actually pass a function which will, let's say, load a page, and meanwhile it will wait for that page load to finish. There might be some timeout. So we have to define our own function that will run under this execute step. And then there is step config. So we can have global configuration, or we can pass individual step config to particular step as well. So this might be like, I want to log my request headers, response headers, bodies, or I don't want to click screenshot, or I want to do certain steps or not. So once you execute this, what happens? It will log the step summary, like when that step started. when that basically execution finished. After execution, did it failed or pass? So this will be part of the logs. So then basically this information is regarding after or before the execution of function that we provided. It will take screenshot before function execute or after function execute. So even you can set this as part of config when you want to do it. Then it will publish these metrics, success percentage, duration percentage, along with any others like 200 responses, any 400 or 500 errors. Also, when we execute that function, there might be some value returned or there might be error or exception thrown. So that will be returned as it is by this function. Let's look into the next one, which is the execute API step. It's similar, same thing, step name, but now we have request option. So in this request option parameter, we pass information regarding that API, the name of host, the method we want to run, get or post, like the path that we want to go through, the port number, the protocol might be HTTP, HTTPS, or other. Then we have callback. In this callback, we verify the response, and then like again, step config. So if we check, what happens is it will execute this HTTP or HTTP request as a step. It will log all the summary, like again, start time, fail, end time, status, if there is any failure, what was the reason of that failure, and then like HTTP call, like request or response headers or their bodies, etc. And same thing, like it will publish all the metrics. Then let's look into the next one. This one is pretty interesting one for me. Like we can sanitize our log reports. There are some compliance and there might be some security things. Let's say we are running against actual environment, we might be getting some sensitive information. So we don't want to capture that as part of our reports, right? So we can use this get sanitized URL. And before that, we need to set this parameter, strict URL parameters. So in this one, like I'm restricting my access token value. And once I pass this URL, like example.com/access token equals to 1, 2, 3, 4, 5. But in my log results, where I get this, it will be access token equals to redacted. So all the information is there, but that access token is redacted out of it. Now, this is a bit more work, right? So every time you have to print or log, you have to use or call this function. But instead, there is another way. So we can use this restrict header at the higher level to define that I want to restrict all of these values, which I will pass as an array from all the headers for both for request and response. So those values will be detected. So example, like again, let's say I want to hide my authorization credentials, right? I just have to pass this list with this authorization as keyword. Similarly, we can restrict the URL parameters. Same again, and this basically works for all the URLs in our logs, in our reports, in errors. And like we can also pass the parameter as well as the path if we want to redirect. We can pass star to redirect everything out of our URLs. Interesting one, right? There are more to explore in terms of library. There is synthetic class. We just discussed 2 out of those, right? Execute step, execute HTTP step. But like there are more, like take a screenshot or add execution error. Then like there is synthetic logger class to sanitize URL, there are error message and headers. We just saw like few of these. Similarly, there is static configuration class that we can use to set config at the global level. But I will leave this to you guys to read and then like, utilize whatever you want for your setup. So you can go and check CloudWatch synthetic Canary Node.js library and Python library, whichever you want to set up. Okay, are we still winning? Or I'm making you bored? Okay, so let's move. Oh, if there is any question now, we can ask. Otherwise, I can move on to the next part. Man, I'm delivering all the information so clear and so smooth that there are no questions. I should be professor at some university, right?
For sure.
All right, let's move on to the next one. The next one, this slide is the one close to my heart. Basically, we are going to discuss some of the security consideration when you are going to do your setup. First recommendation is to use a secure connection, the HTTPS type of connection. So the connection is encrypted. There might be some sensitive information being captured, right? So it's always better to be safe than sorry. Then this Canary name consideration. The idea here is to choose a name that don't showcase your proprietary information. So this Canary name is part of ARN, and that ARN is sent in the header as a user agent. So it's always better to have a name which don't showcase your internal information. If you're going to use any like sensitive or tokens, passwords, try to use basically secret manager. Don't store those naked values into your code. Then keep strict permission for your S3 bucket. So these buckets are where your code is stored, your script is stored, or where you are storing your artifacts. Use object version for your Canary code, so you always know which code is being run in your execution environment. Then again, sensitive information, we just discussed it, right? Use strict URL parameters or restricted headers to redact all those information out of your reports. Then again, Canaries have maximum memory that they can get is 1 gig out of that Lambda, but don't use this 1 gig as your threshold. Try to keep them like really light and simple. Then the synthetic Canary timeout. As we saw in the video recording, that we can set that value. If you don't, then this value is totally dependent on your schedule. So let's say you are running your test every minute, then this will be just 1 minute for you. Okay, so we have seen so much security, how to set up, how it works. But like, there is another factor which basically goes to our credit card, right? We are a startup company, as I mentioned earlier. So the cost is pretty close to our wallet and our heart as well. So in our team, we had used Semaphore. Even we are using Semaphore for certain projects. Then we are also using AWS Core Build. Then we recently started picking up like AWS Synthetic Canary. But if we look into the cost, there is huge difference. So in terms of Canary, we are paying $0.0012 per run. Mind me saying it's per run. In case of AWS Core Build, if we use the smallest possible, which is the ARM compute instance with 3 gig memory and 2 CPUs, we still pay like 0.0034 per minute. And then in Semaphore, if we use the lowest possible configuration, we are paying $0.00125 per second. But if you are running your task pretty frequently, and we are running it like maybe let's say every 4 minutes or every 1 minute, every day of the week, of the month, of the year, and you calculate, seems like the overall cost, synthetic Canary always win. That's what was our calculation analysis. But be mindful, there might be additional costs involved here. There will be alarm, there will be S3 storage or Lambda invokes. But even if we combine these, we found that synthetic Canary was still a winner. Okay, so let's summarize what Kevin did and what does it mean in the end. So AWS Synthetic Canary, verify our application as a client, as a real client. It's a serverless approach. We pay per run. It is fast loading service. If you're running with high frequency, it starts with warm Lambda. It runs with high frequency. We can go as low as 1 minute. And with same amount of code, we can get more benefit. We can get artifacts like logs, screenshot, X-ray traces, and then we can use those screenshots to compare with our base. Okay, questions?
I have a question. When you mean pay per run, does that matter like how short it is or how long it is, or not really?
At the moment, from the AWS documentation, I didn't find anything saying like how much minutes or time is involved, but I think this is still pay per run per step.
Per step?
Yeah.
Okay, cool.
Okay, any other question? But sorry, Matthew, I would also suggest to, I can double check and get back to you on this one as well, just to be on this confirm and on the right side.
Okay.
Okay.
I have a quick question. So when you do the test of get kind of URLs, but what about the post type, like when you do something not idempotent? So do you have any strategy for that?
Yes, API Canary allows us both methods, get, post, they works, yes. You can do any kind of API call there.
Yeah, but I mean, like every time when it tests, it's going to change your system. So do you have to prepare something on the other side? So that's what I'm asking. Like, for example, like the post usually does write something to your system or modify something. So do you have any specific strategy for that part?
This is pretty specific question, but I will try to answer. That might not be a perfect solution. So let's say you post your state change, right? So either you have to manage your tests in a way that you are aware of that state change, so you can make another GET request, get the new values, and expect what should be there in the next API post call. Or I would say, let's say the easy way out of this is like have a fresh environment always before you make your test.
Okay, so it means like you have to organize the sequence of your tests, right? So
Yes.
okay, got it.
Harman, if the state change is in a database, would you be able, in theory, to connect to the database and check whether the action actually made the change?
If there is an API, we can make any kind of API call from static Canary. But if it is, let's say we are doing DynamoDB, then no, it's an internal service, and Canaries do not have any access. Even if you are part of same VPC, you still cannot do that.
I see. Thank you.
Okay. All right.
One more. Sorry, Harman. One more question.
Sure.
While you were showing the demo, I saw like you used the example.com as an example for your canaries. So does it mean like you were actually calling example.com, or you fixed something in the DNS so it would just forward to your internal service, or what did you do with that part?
It was actual call to example.com. And if you check in my path, it was just like only example.com. If I go, let's say, to a particular path, it will fail. Yeah. Nice catch, by the way. You have good eyes.
Thanks.
All right. Okay, let's try to move a bit more further. Now we are finished with the chapter 2 from Kevin. Let's look into what do Dave have to share with us, which is the chapter 3. So now Dave is going to work on the service level test layer, and he's going to share the information regarding LambCI Lambda, how do we implement and how do we run it locally. Okay, same question. Hey Harman, we ran our test at system level. Why do we need to run test at service level? Okay, the answer is we want to verify our functionality here. We want to validate our code changes even before going to production, before deployment. So we run in local environment with same strict environment as production, and we try to verify same behavior as we do after the deployment. Okay. Now let's talk about LambCI Lambda, what it is. So it's a containerized application, it's basically a sandbox that local environment which replicate live AWS Lambda environment. We can install software libraries and packages. It follows same file structure, permissions, and environment variables. And then we can run in two modes. Like we can just run it one single execution, or we can run it as an API server, which basically can listen to invoke events. Okay. If we have to run it locally, it's a simple command, just docker run. Use this image, LambCI Lambda, and then like you can choose Python or Node and the version that you want to run against. Provide the name of handler or any event like payload context information that you want to send in. For your code, you have to mount that code to this path, where/task, and then for layers, you have to mount at the opt folder. I'm running, it's like the recommendation is to, like we are using this -rm. Basically, we want to make sure that after the run is complete, we want to remove those containers. And then there is RO delegation. This basically means we mount our directory for read-only purpose. And if you want to run it, this is like a single run. If you want to keep it running as a local API server, then like all you need to do is pass the environment variable, which is docker lambda stay open equals to 1. So, and you don't need to pass event will be passed by the invoke call. Then it will keep on running as a API server. All right, time to do some demo. Okay. Let me share the piece of code. I have a simple Lambda, which basically for every call, it will return me 200 status and hello world. I have masked my IP location here, so it would just send me ** for that. So this is simple Lambda code. Then I'm not running a Docker directly, but I'm using Docker Compose here. So this is the Docker file. I'm using LambCI Lambda image, Python 3.8, running as a root user, set my environment, set my working directory at the path where my code will be, and then I just install my packages. If we look into the Docker file, Docker Compose file, so pretty much everything is same, but few things. The command I'm running here is I'm just calling my Lambda handler function, and then the volumes. So my code is mounted at this particular location, which is where task. If I had any layers, then they will be mounted to /opt location. And now my makefile. Pretty simple. Let's run them, sort of showing them. So first thing, I'm going to build my Lambda. Sorry. So it will run my Docker file, create the environment that I need for this. Boom. So all this stuff ran, everything fine here. Now let's say I just want to run it for one time. So again, make Lambda and then run it. Boom. So here I can see the start, then the end, then a report, which basically give me the initialization time, the total duration, the billing for which I will be paying, the memory use, and max memory use, right? So this is pretty neat. Now let's just run it as a stay open server. Okay, now it is listening at API port 9001. Let me open my another terminal. So here I'm going to use curl command to invoke my Lambda. So I just run a curl command at a particular location path. And here we were able to see logs being generated, right? So let's do one more time. Okay, sorry. For this demo purpose, I just use curl command, but you can also use AWS CLI for this purpose. Okay, go back. Demo is over, and the chapter is also over. So let's summarize this one. At service level test layer, we have LambCI Lambda. It's a cost saver because we can run test against our service locally. It runs a containerized test, and we can verify Lambda serverless resources. We can verify code changes even before deployment. Questions? Nice. When there are no questions, that's really nice. Either I'm doing really dummy job or I'm doing really great job. I feel the first one or the second one.
Very clear. It was very clear.
Very clear. Okay. All right. Let's have a conclusion on this one. So far, we have two, basically introduction. We went through system level, service level. So what are the conclusion at high level? AWS Synthetic Canary are their core sufficient serverless solution. LambCI help us to test at more granular level, and minions are awesome. So be like minions. One last thing. Appendix, those are my 2 cents. So if somebody who's from Amazon or AWS listening to this talk, or you have links there, I have a feature request to make. First feature request is to be able to invoke synthetic canaries. Currently, they run on schedule or on a cron job or run just once. But if we can invoke them, then there is potential to remove AWS core build out of test equation and save more money. And second thing is not that high, but like, again, it would be nice if we can improve the HAR HTTP archive if we port file logs. Currently, let's say if you have 2 steps, the second step logs are combined into step 1. So they are the subset of step 1, but like it would be nice to see them separately. And then lastly, I have a recommendation for everyone. This is to use synthetic canary for smooth testing. Keep it light, keep it simple, and be awesome. And my hands are up.
Thank you so
All
much,
right, any
Harman.
questions?
Thank you for such a detailed talk, actually, with all the examples. That was great. And are there any questions from the audience otherwise?
I have one question about
Sure.
like testing services. So I think there are lots of like testing services other than AWS ones, or like WebDriver.io or Cypress.io. Is there any like points you find like AWS is superior to those services, or any your favorite features compared to those? I'd love to hear that.
Yes. If we talk about the AWS side, and especially focus on the synthetic canaries, the one major factor is that you have a pre-built environment. So you already have a Lambda, which is already loaded with the library and packages. So it just runs. So that saves us a lot of loading time and execution time. And the second one was like we can run on high frequency that cost us still low as compared to other. So these are the two major factors that I like about it. But yeah, definitely there are other resources that we can use. But these are the two major consideration point that I will share at this point.
So compared to other services, you feel like AWS is much cheaper, or?
So far, based on my experience, I haven't used like other ones, but like so far it seems like. But again, that depends on what kind of options do you have. So I might not be going in depth here because I cannot say with 100% assertion here.
Yeah, thank you. Yeah, that's really nice to hear from the one actually using the service.
Thank you.
Yeah, in terms of cost, it's hard to estimate.
Like I compared the semaphore, AWS core build, and synthetic canary because we use them, and now we are looking into more options.
Cool.
Thanks for great comments. I'm just reading those now.
Have you considered actually building something like puppeteering, like setting it up in EC2 and building like yourself, like without using this managed service?
The idea is yes, we can do that. Totally, we can do that. But again, that's depend upon the comparison on how much efforts you want to put in, or you just want to use already built-in solution and save time. Another part is, let's say, if you use your own EC2 instance and then like install everything and do all this stuff, you make your efforts and write your code. In the end, the cost is another factor. So you have to consider cost, like cost of the development and cost of running it on the longer basis. So to summarize, I would say I haven't considered, but based on a little bit of search from our side in our teams or in other teams, we see that like just using this already present solution is time saver and cost saver for us.
Yep, got it.
Any others?
Otherwise, I can go and eat my pizza.
Yes, it's probably cold. Well, thank you so much, everyone. Thank you for attending. Like I said in the beginning, this is the last event for the year. We'll probably see you January. We're still scheming, lining up the next talks. But yeah, wish you all the best for the rest of the year and the new one. Otherwise, it's a bit early, I know. But thank you very much, and thank you for participating. And thanks, of course, for Harman for this excellent talk. I learned something myself.
Thank you so much, guys, for attending. Thank you.
See you guys.